Good morning students. This is first lecture of chapter complex number. So before going to start complex number, let us recall real number. And then we will see what motivated mathematician to develop a new type of number, that is complex number. Clear? So what is real number? So all the rational number, irrational number, integer, fraction, whatever you have read till class 10, clear? Those numbers are called real numbers. Now, what is an important property of real number? So an important property of real number is that square of any real number is always positive. Whether the real number is negative or it is positive, its square is always positive. See, -1 is a real number. Clear? Now, after squaring it, it will be a plus 1. So, -1 is negative real number, but after squaring it becomes positive real number. Clear? -√2. Clear? It is a real number, negative real number, but after squaring it becomes √2. So square of any real number is always positive. Clear? Now question arises, is set of real number a complete set of number? It means, can we do all the calculation of mathematics in the set of real number? So let us take an equation, x square plus 1 equal to 0. Now can we solve this equation in the set of real number? Is there any number in the set of real number which will satisfy this equation? Then answer is no. There is not any number in the set of real number which will satisfy this equation. Why? Because if x is real number, then of course x square will be a positive number, it will be a positive number, and 1 is also positive number, and sum of two positive number cannot be 0. It means there is not any number in the set of real number which will satisfy this equation. We cannot solve this equation in the set of real number. Clear? It means the set of real number is incomplete set of real numbers. We cannot do all the calculations, clear? All the mathematical calculation in the set of real number. So we need some extra number which can handle this type of situation. And this motivated mathematician to develop a new type of number, and that number is known as complex number. In the set of complex number, we can do any mathematical calculation. So, before going to start complex number, here let us discuss imaginary number, purely imaginary number. So, topic 1. Our first topic is purely imaginary number. Purely imaginary number. Imaginary number. Now, which type of number is called purely imaginary number? So, the definition is square root of negative real number. Negative real number. Real number is called purely imaginary number. Purely imaginary number. For example, square root -1. So -1 is a negative real number, and after taking its square root, this whole number will be what? square root, this whole number will be what? Imaginary number, purely imaginary number. Square root minus 1 by 2. Clear? It is also purely imaginary number. Minus pi, it is negative irrational number, and irrational number is also a part of real number. Now after taking its square, it will be purely imaginary number. So these type of numbers are known as purely imaginary number. Now what is the characteristic of purely imaginary number? Its square will be always negative. Square of purely imaginary number is always negative. Square of purely imaginary number is always negative. For example, root under minus 1, it is a purely imaginary number. After taking a square, it will be minus 1, which is negative. The square of minus 2, it is purely imaginary number. After taking a square, it will be minus 2. Purely a negative real number. So, square of purely imaginary number is always negative. Clear? Now, imaginary unit. Now, imaginary unit. In the same topic, right? Imaginary unit. It is denoted by the Greek letter iota. Now, what is imaginary unit? So, square root of minus 1. Clear? Is called imaginary unit, and Euler was the first mathematician who introduced a symbol iota for this imaginary number. Clear? So this imaginary number is known as imaginary unit and denoted by a Greek letter iota. Looks like the letter I, but it is read as iota. So this is called imaginary unit. Clear? Now, why it is called imaginary unit? Because this imaginary number is present in all the purely imaginary number. This is called pure imaginary unit because any purely imaginary number can be expressed in terms of iota. Clear? See example. Square root minus 4. It is a purely imaginary number. It can be written as square root 4 into square root minus 1. Clear? Now it is positive square root of 4, so its value will be 2, and it is equal to iota, so 2i. Square root minus 1 by 4. It can be written as square root 1 by 4 into square root of minus 1. Now positive square root of 1 by 4 is 1 by 2, and this is iota. Square root minus 3. It can be written as square root 3 into square root minus 1. So it is square root 3 iota. So each evaluation of positive integral power or you can say, now we are going to discuss integral power of iota. Integral power of iota. Integral power of iota. Clear? Now we are going to let me discuss in easy way. Evaluation of positive integral power of iota. Positive integral power of iota. Evaluation of positive integral power of iota. So before going to discuss the bigger positive integral power, let us take smaller positive integral power. Clear? Now iota to the power of 1. What will be its value? So it is equal to iota only. Now iota square. So we know that iota is what? Root under minus 1. So after squaring it will be what? Minus 1. Now iota cube. So iota cube can be written as iota square into iota. And iota square is minus 1 into iota. So it will be minus iota. Now iota to the power 4. Clear? So it can be written as iota square whole square. That is minus 1 square, and that is 1. So iota to the power 1 is iota itself. Iota to the power 2 is what? Minus 1. Iota to the power 3 is minus iota. Iota to the power 4 is 1. Clear? Iota is an imaginary number. Value of iota square is minus 1. It is a real number. See, minus 1 is real number. Square root of minus 1 is imaginary number. Square root of only minus 1 is real number. Now it is also imaginary number. And it is real number. So one thing is clear. Some of the power of iota are real, and some of the power of iota are imaginary. Now suppose bigger powers are given to you. This we can memorize directly. Iota to the power 1 is iota. Iota square is minus 1. Iota to the power 3 is minus iota. Iota to the power 4 is 1. Now what about if bigger powers are given to you? Clear? In that case, what can you do? Suppose bigger powers are given to you. Suppose you have to evaluate iota to the power n, where n belongs to natural number. Clear? Positive integer. 1, 2, 3 like that. So if this power is bigger numbers, say up to 4 directly we are going iota to the power 1 is iota, iota to the power 2 is minus 1, iota to the power 3 is minus iota, iota to the power 4 is 1. So these 4 we are going directly. But what about if bigger power is given? So if this power is bigger, what you can do? Divide n by 4 and find remainder. Remainder r. Now 4 possible remainders are there. When any number is divided by 4, there are 4 possible remainder. Remainder may be 0, remainder may be 1, remainder may be 2, and remainder may be 3. So if remainder is 0, in this case iota to the power 1 will be 1. If remainder is 1, then in this case iota to the power n will be iota. If remainder is 2, then iota to the power n will be minus iota. Minus 1. And if remainder is 3, iota to the power n will be minus iota. Clear? So in this way you can find the bigger power, you can evaluate the bigger power of iota. Example. Suppose you have to evaluate iota to the power 39. What is the value of iota to the power 39? So divide 39 by 4. So the remainder will be 3. Of course the remainder will be 3 because 4 9 36. So remainder is 3. Now, so when remainder is 3, the value of iota to the power n is what? Minus 1, minus iota, so it will be minus iota. So iota to the power 39 is equal to what? Minus iota. Now, suppose you have to explain why it is minus 1. Directly we have memorized this result, clear? But suppose you have to explain why in this case it is minus iota. So you can explain in this way. Iota to the power 39, it can be written as iota to the power 4 whole to the power 9. So 9 4 36 into iota to the power 3. So 36 plus 3 it will be 39. Okay. Now iota to the power 4 is 1. Value of iota to the power 4 is 1. So 1 to the power 9 into iota and value of iota to the power 3 is minus iota. So it is equal to minus iota. So in this way also you can explain. Clear? Now take one more example. Suppose we have to evaluate iota to the power 2021. Clear? So what will be its value? So when 2021 is divided by 4, clear? Then of course the remainder will be 1. Clear? Here the quotient will be what? Quotient will be 504. Quotient will be 504. Clear? So it is, and the remainder is 1. So when remainder is 1, the value of iota to the power n will be iota. So it is directly equal to what? It is directly equal to iota. Suppose you have to explain. Suppose you want to explain why this is equal to iota. So you can explain in this way: iota to the power 2021, it can be written as iota to the power 4 whole to the power 5000. It is not 4, it is 5. So 5005 into 505 into 4 will be what? 2020 into iota. Clear? And its value is 1. So 1 to the power 505 into iota. So it is equal to iota. So in this way you can explain. Now evaluation of negative integral power. Negative integral power of iota. Suppose if we have to evaluate negative integral power of iota to the power minus a. Clear? So before going to evaluate this, clear? First of all, simplify 1 by iota. How can we simplify 1 by iota? So 1 by iota can be written as 1 by iota into iota by iota. To simplify 1 by iota, what we can do? We can multiply numerator by iota. Now 1 into iota will be iota, and iota into iota will be iota square, and we know that iota square is minus 1, so finally we are getting what? Minus iota. So always remember, directly memorize it, 1 by iota equal to minus iota. 1 by greater than 0. All these are meaningless. These relations are invalid. Clear? These relations are meaningless. It has no meaning. So iota is positive, negative, 0. These are meaningless. It has no meaning. Now the second iota to the power n, where n belongs to any integer, can have 4 values only. 4 values only. And these values are 1, minus 1, iota and minus iota. Whatever is the integral power of iota, it can have 4 values only. Now, next property 3. Property 3. Sum of 4 iotas having consecutive power is consecutive integral power is 0. That is iota to the power n plus iota to the power n plus 1 plus iota to the power n plus 2 plus iota to the power n plus 3 is equal to 0, where n belongs to any integer. So sum of 4 iotas having consecutive power is always 0. Now we can prove it. See, iota to the power n plus iota to the power n plus 1 plus iota to the power n plus 2 plus iota to the power n plus 3 powers are consecutive integers. The iota to the power n plus it can be written as iota to the power n into iota to the power n into iota square plus iota to the power n into iota cube. Now take iota to the power n common, so we will get here 1 plus iota square and plus iota cube. So iota to the power n 1 plus iota and iota square is minus 1, iota cube is minus iota. So this cancels with this one, so it is 0. So sum of 4 iota having consecutive power is always 0. So take example. Now iota to the power 2021 plus iota to the power 2022 plus iota to the power 2023 plus iota to the power 2024. What will be its sum? So immediately we can answer 0. Iota to the power minus 100 plus iota to the power minus 101 plus iota to the power minus 102 plus iota to the power minus 103. What will be sum? Immediately we can answer 0. Iota to the power minus 2 plus iota to the power minus 1 plus iota to the power 0 plus iota to the power 1. What will be sum? 0. Clear? So we have discussed the concept of iota. Clear? Now in the next lecture we will start complex number, the definition of complex number, and its